Okay, today we are going to discuss integration by parts. For that, you have to recall the formula of integration of the differentiation of product of two functions that you have done in chapter number 4, which is this one. So if we integrate, that gives this one, and by rearranging we get this sentence, and by putting dw upon dx with we get this sentence, which can be written as or we can say that the first function multiplied by integral of the second function minus derivative of the first function multiplied by the integral of the second function as a whole. So now to find the integral of this function, which is a question of question 1, part 1 of exercise 6.7, that's a Karachi board mathematics FSA part 2. Let's take the function where the u equals L and x, and take v as x, right? So now taking the to put this function into this formula, we have to find certain parts by taking the derivatives. So by taking derivative, so we have supposed u equals ln x and v equals x. So taking the derivative of u, that gives us 1 upon x, and integral of v d of x, that gives x plus 1 which is x square upon 2. So now putting these values into the formula, which is the standard formula for integration by parts. So putting the values, that is x ln x d of x. So what's the value of u? That is ln x, and the integral of v, which is x square upon 2 minus integral derivative of u, that is 1 upon x into integral of v, what we have calculated, that is integral of u, that is integral of x d of x a whole dx. So now just rearranging this, ln x upon 2 minus integral of 1 upon x, and that's the integral of x is x square upon 2 d of x square ln x whole divided by 2 minus integral of this, cancel out this x and 1x from here, that will give us x upon 2 d of x. Take this 1 upon 2 outside the integral, x square ln x upon 2, that gives 1 upon 2 integral of x dx upon 2 minus 1 upon 2, that is x square upon 2 plus c. So x square ln x, that is minus x square upon 4 plus c. So this is our final answer. Okay, doing this question now, taking u equals tan inverse x and v as x square. So now taking the derivative of u, that gives us 1 upon 1 plus x square, this is 1, on the integral of v is that gives x cube upon 3, right? So now using the formula by parts, u into v d of x, that is u into integral of v minus integral of du upon dx integral of v dx whole integral. So now the putting the values, what is u, that is tan inverse of x, integral of v, that is x cube upon 3 minus integral of du upon dx, that is 1 upon 1 plus x square, and integral of this v is, that is x cube upon 3. We are putting the integral directly as we have calculated over here, and dx, that is tan inverse of x, x cube upon 3. Now putting the values, taking this 3 outside the integral, that is x cube upon 1 plus x square dx. And now you can see this is an improper fraction, so we are making it proper first. Improper fraction converted into a mixed fraction, rearranging this part 1 upon 3. So if you divide x cube by 1 plus x square, that gives x minus x upon x square plus 1. If you are confusing yourself, then how do I obtain this part? Let's do it over here, right on the over up here. Just divide this x cube by x square plus 1, so you will get this part. Okay, so x square, x the x cube plus x cancel out, and we are left with x. So I can write this as a x minus x upon x square plus 1, right? So continuing with the integration of that part also, that will give us x dx minus minus plus 1 upon 3 integral of x upon x square plus 1 d of x. So further solving this, x cube tan inverse x upon 3 minus 1 upon 3 x square upon 2 plus 1 upon 3, that gives us if we multiply this part with multiply and divide this part with 2, this will give us again this, take this 1 upon 2 outside here, 1 upon 2, and I'm left with 2x upon x square plus 1 d of x, which is ultimately, which can be written as tan inverse x upon 3 minus x square upon 6 plus 1 upon 6, that is ln into x square plus 1 plus c, which is our final answer. Okay, now this is our fourth question. Taking u equals tan inverse of x and v is equal to x cube, taking the derivative du upon dx, that is 1 upon 1 plus x square, and integral of v, or that is dx, that is you can write it as 4 upon 4. Okay, the formula is the same, u v dx, that is given function, first function into integral of the second function minus integral of the derivative into integral of the second function and taking the integral of the whole part, right? So now putting the values, that is the first one is, second these two values, first put the original function, that is tan inverse of x, and the integral of the second function, that is x power 4 upon 4 minus integral of, what is the derivative of the second function, that is 1 upon 1 plus x square into integral of the second function, that is x 4 upon 4 dx. So x power 4 tan inverse x upon 4 minus, take this 4 outside, 1 upon 4 integral of x power 4 upon 1 plus x square dx. So x power 4 tan inverse x upon 4 minus 1 upon 4, right? So dividing this part again in the same way we have done the previous question, dividing this x power 4 by 1 plus x square, that will give us a part, let's do it here, x power 4 divided by 1 plus x square, that will be x squares x power 4 plus x square, subtracting, that will give us minus x square, x square minus 1, that will minus x square, minus into minus 1, and that will give plus here, cancel out, we are left with plus 1 as a remainder. So now writing, this is our answer, which is x square minus 1. The 1 is positive, so we will write plus here, 1 divided by this 1 divided by 1 plus x square. Okay, so this is the integral we have dx here. So now taking the integral, so we will write this x power 4 tan inverse of x upon 4 minus 1 upon 4. Now applying the integral with on all parts, this one and this one, so we will have x square dx minus integral of 1 dx plus integral of 1 upon 1 plus x square dx, x power 4 tan inverse of x divided by 4 minus 1 upon 4, taking the x cube upon 3 minus x plus minus that is, so plus, plus, that is, you can see this is an inverse function, that is tan inverse of x upon tan inverse x, okay, plus c. So now applying this 1 upon 4 on each term, x power 4 tan inverse x upon 4 minus x cube upon 12 minus plus x upon 4 minus plus minus tan inverse x upon 4 plus c. This is our final answer. Okay, now for this question, part 5, exercise 6.5, taking u as ln x and v as x square, and taking the derivative du upon dx, that is 1 upon x, and integral of v d of x is, that is x cube upon 3, integral of u into v d of x, that is u v d of x, minus integral of du upon dx v dx. Now putting the values into the formula, that is u is equal to ln x, integral of v of dx, that is x cube upon 3 minus integral of du upon dx is, that is 1 upon x, integral of v of dx, that is x cube upon 3 dx, that is ln x, that is x cube upon 3 minus integral of x, and this one x cancel out here, and that gives x square, and take this 1 upon 3 outside here, d of x ln x, write this x cube on this side, minus 1 upon 3 integral of x square, that is x cube upon 3 plus c x cube ln x upon 3 minus x cube upon 9 plus c. This final answer.